Welcome to Cambridge Chemistry channel with Sarvat Ahmed. Be sure to like the video and subscribe it. Really helps the channel to grow. Today I will discuss the qualitative analysis of P3 question paper 3. You know that qualitative analysis is the process in which you are going to identify the cations and anions present in the salt solution. So we have cations and anions in the given solutions, and these are the cations and anions test, and their observations are given at the end of the paper. So you can take help from this table or from these notes as well, uh, but before starting the experiment you should have some points in your mind. So today I will discuss basics knowledge of cations, that what you should have in your mind before starting the questions. So let's start. So you know that cations are identified by using reagents sodium hydroxide and ammonia solution, and you should know that there are three types of observations whenever we dealing with the cations, like by using sodium hydroxide and ammonia solution. For example, first of all you should know about the cations present in your syllabus. So these cations are present in your syllabus. So these cations are in your syllabus. So to identify these cations, we add, first of all we add few drops of sodium hydroxide. So there are three types of observations are there. White precipitates, colored precipitates, and no reaction. So if you, there is barium as well. If there is no reaction, so कोई change आपको नज़र नहीं आ रही, तो it means the solution contains barium ion and ammonium ions with addition of few drops. And if the white precipitates are when you add sodium hydroxide, if white precipitates, you observe white precipitates, so it means white precipitates solution must contain aluminum ion, calcium ion, magnesium ion, and zinc ion. And if colored precipitates are formed, then there will be solution contain iron 2 ion, iron 3 ions, chromium 3 positive, and copper 2 ions. And you know, white precipitates, if your solution या FA, any FA solution contain white precipitates, you must have these cations in your mind. So if we add excess sodium hydroxide, So when you add excess of sodium hydroxide, so uh, some precipitates dissolves and some remain insoluble. The precipitates which dissolves, PPTs dissolves, are zinc ion and aluminium ion. And if precipitates remain insoluble, PPTs insoluble with excess of sodium hydroxide, then solution must contain calcium ion and magnesium ion. So to identify these zinc ion, because we have two ions which dissolves in excess of sodium hydroxide, so we carry out test with aqueous ammonia. So we take fresh solution of these cations, or the solution which contain which have PPTs dissolves, white PPTs dissolves. So we will further confirm with the aqueous ammonia, few drops of aqueous ammonia. So when we add aqueous ammonia, the same results, that white PPTs are formed. White PPTs form, and obviously solution must contain zinc ion and aluminium 3 positive. And when we add excess of ammonia solution, if PPTs dissolves, PPT is soluble, then the solution must contain zinc ion. And if the solution precipitates remain insoluble, the given solution contain insoluble, the given solution contains aluminium ion. Now similarly, we can differentiate these two cations, that whether calcium ion is present or magnesium is ion. So we will confirm the ions by using few drops of aqueous ammonia, to the fresh solution. When we add few drops of ammonia solution, if there is no reaction, so it means calcium ions are present. And if there is white precipitates remains, white PPT is insoluble, then it must contain magnesium ion. So you should have all these points in your mind while performing this question, while identifying the cations, white cations. Now come back to the ions which has no reaction at all. So there are two ions in your syllabus which have no reaction with few drops of sodium hydroxide. Then if we add excess sodium hydroxide and plus warm the solution, if the solution gives excess sodium hydroxide and warm the solution. And if the observations are gas is evolved which turns damp red litmus paper blue, it must contain ammonium ions. So it means it has ammonium ion. And if with addition of sodium hydroxide and warming the solution, if there is no change, no reaction, it must have barium ion. And to further confirm the barium ion, if we add, this is the confirmatory test of barium ion. Or if you confirm the that solution contain barium ion, then add dilute sulfuric acid to the given solution. If the white precipitates are formed, the solution if the white precipitates conform barium ion. So in this way you can identify the solution which form white precipitate and solution which have no reaction. Now come to the colored ions. So let me now if colored precipitates are formed, then it must contain transition metal ions. So if solution contains, if colored PPTs are formed with addition of few drops of sodium hydroxide. So colored PPTs are iron 2, manganese 2, iron 3, chromium 3 positive and copper 2 positive. So we know that the color of these ions, manganese form of white PPTs, iron 2 form green PPTs, and if red brown PPTs, it contain iron 3 ions, and if again green PPTs, for chromium ion, and copper ions have blue PPTs. Blue PPTs. Now when we add, if we add excess of sodium hydroxide, so we have two types of observation. PPTs dissolves and pipit is insoluble. So with the same color, pipit is dissolves with the same color. For example, pipit is insoluble are manganese 2 positive, iron 2 positive and iron 3 positive. And copper 2 positive. Same off-white. Please keep it in mind that off-white pipitase turn brown in case of manganese. Turn brown pipitase. It can be pale yellow as well, so you must careful while observing these cations. If first off white and then turn brown, it must contain manganese. So don't confuse with the iron 2 and iron 3, because iron 2 afterwards, iron 2 again, iron 2 green pipitase, but after some times it is oxidized to form brown, red brown pipitase, because iron 2 is further oxidized to iron 3. So that's why finally if stand for sometimes it turns red brown, and iron 3 is the same red brown pipitase. So please you should be very careful while identifying these three cations, manganese, iron 2 and iron 3, because manganese first of white or pale yellow, then afterwards it turn brown when stand in air or when react with air. Similarly, iron 2 first immediately form green precipitate, which oxidized further if stand for some time, precipitates turn red brown. So please you should be very careful while uh, identifying these cations, iron 3, iron 2 and manganese. Copper 2 has blue precipitate, insoluble, blue pipitase insoluble. So the pipitase which dissolves are chromium, only chromium 3 pipitase dissolve in excess of sodium hydroxide. Now afterwards we will perform the same type of test with the aqueous ammonia. Manganese 2, iron 2 positive, iron 3 positive, chromium 3 positive and copper 2 positive. Few drops of ammonia, same pipitase, colored pipitase, so all form the colored pipitase, sorry, with few drops of ammonia solution. When you add few drops of ammonia solution, colored pipitase, with particular colors, you should know about the color of these cations in your syllabus. Very common color, manganese form of white and remain insoluble, turn brown, of white, pale yellow, turn brown. Excess ammonia of white or pale yellow turn brown with air. Iron 2 form green precipitates, green PPTs, and if we add excess ammonia, same green PPTs insoluble. Iron 3, and it also turns brown if solution turn brown with air. Iron 3 form red brown PPTs, and with excess ammonia, again red brown PPTs insoluble. Next we have copper. Pale blue PPTs with few drops of ammonia solution. Blue PPTs, and when we add excess ammonia, pale blue PPTs dissolves to form deep blue solution. And one ion is left, that is chromium. Chromium 3 ions, green precipitate, and if we add excess ammonia, green PPT is insoluble. So these are the cation results. When you add, if similar results are obtained, you should identify in such manner. And if there is if sodium hydroxide and ammonia reagents are given along with the test, you should know that it is of cation test, that any cations are present. So इसलिए आपको उसके अकॉर्डिंगली जो है वो ऑब्जर्वेशन आपको माइंड में रखनी है, सारी ऑब्जर्वेशन, और अकॉर्डिंगली आपने जो है वो आइडेंटिफाई करना है कि इफ़ सोडियम हाइड्रोक्साइड और अमोनिया सोल्यूशन एट, सो दैट सोल्यूशन contain cations, because sodium hydroxide and ammonia solution are used to identify the cations. So hopefully you understand the how to identify the cations.